So now we want to deal with multiplying or dividing fractions. And the rule goes, if you have two numbers, a over b times c over d, whatever they are, you don't need no lowest common denominator, or you don't even need a common denominator. And you can just treat them separately. A times c over b times d, and then that'll give you some number over some number. There's no need to find any common denominator because you're dealing with multiplication. Now division, if you have a over b divided by c over d, uh, you just flip the second number, so you inverse the second number, and the division becomes multiplication. So a over b, these two are equal, times b over c. So for example, if you had 1 over 2 divided by 5 over 9. That's the same as 1 over 2. Now you flip times, and then you flip the second number. So that becomes 1 times 9 over 2 times 5, which is essentially 9 over 10. So that's the rule for division. Just remember to multiply and then inverse the second. Now you might look at division and you get something like, you might get 1 over 2 over 5 over 7. Fractions, like I said before, is just a really way of saying divide. So you can just write this as it makes you feel more comfortable, and then do the flipping. So those are just the rules for multiplying and division. So let's just go over an example. So 7 over 2. And if you have a mixed fraction, like I said before, anytime you're adding or subtracting, multiplying, dividing fractions, you just switch it to a fraction, whether it's proper or improper, it doesn't really matter. So 7 over 2 times 5 over 8 divided by what? 3, for example. And we know that 3 is really 3 over 1. You just don't write it. So what is that equal to? That's 7 over 2 times 5 over 8 times, and then since 3 is 3 over 1, you just flip it, 1 over 3. And again, you don't have to find nothing common about it. Just separate them. 7 times 5 is 35. 16 times 2 times 8 is 16, times 3 is 48. That's your final answer. Now you could just keep using that general formula. That's just a general way of doing it, and then at the end reduce if you have to. Or you can do reducing early on, and it makes things a lot easier. And here's why. So let's just take an example. 2 over 5 times, what do we got? Times 3 over 8. Okay. Well, when you see that, if you're good with seeing this, you'll know, hey, 2 is divisible by 2 once. 8 is divisible by 2 4 times. So that's really 1 over 5 times 3 over 4, 3 over 20. So why can you do that? Why can you, and it doesn't matter if it was 2 over 5 times 1 over 7 times 3 over 8. They can be away from each other by another fraction. It doesn't really matter, because this is essentially the same as saying nothing really changed. You're still multiplying. So like if you had 1 times 7 times 9, that's the same as if you switch the order. It's it's comes to multiplication, order is not really relevant when it comes to multiplying numbers like these, and in this situation like this. So why can you do that? If you're already comfortable with knowing why you can do that, reducing and then doing that, you're fine for this video. But if you want to have a more in-depth look and kind of understand every time what you can use and what you can't use, just watch the second part. So you'll have 2 over 5 times 3 over 8. So let's just say we wanted to do it, the general way. So, 2 times 3 over 5 times 8. Now, look at the bottom part. So nobody would argue that, 5 times 8 is not equal to 8 times 5. We know that these are equal. Order doesn't really matter. So I'll do this. 5. And then now I'll break them apart into fractions again. And you really didn't do anything. Essentially, you just switched the ordering, but you're allowed to do that because you didn't break any rules. You didn't add when you weren't supposed to. So then you look at that and you say, hey, 2 is divisible by 2 once. Then 8 is divisible by 2 4 times. Kind of makes it easier to see that divisibility part. And that's the same as that one. So what I'm basically trying to say is 2 over 5 times 3 over 8 is the same as 2 over 8 times 3 over 5. You could have got either one of these questions. It leads you to the same answer. When you're dealing with multiplication, you can just throw denominators around. It doesn't really matter. If you had division, let's just say for example, 2 over 7 divided by what do we got? 10 over 21. So now you know how to do the general way. So switch it to times 21 over 10. And now either you can do this the long way of flipping them around, or you can see, hey, 2 and 10 they'll cross from each other. 2 goes into itself once. 2 goes into 10 5 times. 7 and 21. 7 goes into itself once. 21 goes to 7 3 times. So you got 1 times 3, 1 times 5, which is 3 over 5. Essentially what we did here is, 2 over 7 times 21 over 10 is 2 over 10 times 21 over 7. You haven't broken any rules. You haven't done anything you're not supposed to. This just makes it easier. You just switch the ordering. This just makes it easier to see how one can reduce into something like that.